Assalamualaikum, we are from Group 5. My name is Ahmad Daniel Yassin bin Suhaimi, and today we will be presenting our group project 2, that is latest automotive emission control technology, and our system or technology is secondary air management system. So I will pass to my friend Zikri to start from.
Hello, my name is Mohamed Zikri. I want to present introduction about SAM. What is SAM? SAM is short form for Secondary Air Management System. This system developed to reduce harmful emission produced during the cold start phase of internal combustion engine. Cold start are known to be one of the most polluting stages of engine operation because combustion is less efficient and emissions are higher when the engine its components are cold. The primary purpose of the secondary air management system is to introduce additional air into exhaust system during cold start. This extra air facilitates the combustion of unburned hydrocarbon and carbon monoxide in the exhaust gas by promoting a more complete burn. The introduction of secondary air helps to raise the temperature of the exhaust gas and accelerate the activation of the catalytic converter. Problem statement and key challenge for SAM. First, system optimization. There is a need for the optimization of the secondary air management system to ensure the precise and controller injection. The secondary air during cold start maximize the efficiency of combustion and catalytic converter activation. Second, energy efficiency. Improving the energy efficiency of the air injection pump or valve to minimize the impact on overall vehicle fuel consumption and performance. And next, second, sensor integration. It enhances the integration of sensor to real-time feedback on exhaust gas temperature and fuel ratio and other relevant parameters for adaptive and efficient SAM operation. And last, durability and reliability. Addressing concern related to the durability and reliability of SAM component to ensure consistent and long-term performance under various operating conditions. Objective on the research: first, to develop and optimize control strategy for precise and adaptive secondary air injection. Second, to improve the energy efficiency of some component to minimize the impact on fuel consumption. And next, improve the enhanced sensor integration for real-time monitoring and feedback. And last, address durability and reliability concerns through improved component design and material. Significance of the study. Here are some significant aspects of the study. First, emission reduction. SAM play a crucial role in reduction emission, particularly during the cold start phase when engines are less efficient. And optimize the system can lead to more effective combustion process, resulting in lower emission of pollutants such as hydrocarbon, carbon monoxide, and nitrogen oxide. This aligns with global effect, mitigate air pollution, and address climate change. Second, environment impact. The reduction of harmful emission directly contribute to improve air quality and reduce environmental impact. By optimize SAM, the automotive industry can actively participate in sustainable practice and meet increasingly stringent emission standards set by regulatory body worldwide. And last, energy efficiency. Efficient secondary air management system can contribute to overall energy efficiency in vehicle by minimize the energy consumption of the air injection pump and optimize the combustion process, and the system can help enhance fuel efficiency during cold start. Okay, I will pass to my next friend.
I will start with my part, that is 3.0 methodology, and we choose about optimizing the system, which is our system, secondary air management system. So we start with, first of all, we start with research design overview. So as you know, the secondary air management system, during cold start for the engine, the engine runs rich, which means it use more fuel than necessary for proper combustion. When it run rich and use more fuel, it increase emission and it affects the performance of the engine. From the research design, we can use the experiment to judge the effects of secondary air management system if it been optimized. And we can determine the control factors like temperature, ambient temperature, engine type, and vehicle model for consistency. Okay, next is system modeling and simulation. We can use mathematical modeling that will develop mathematical models to simulate the behavior of the secondary air management system under various conditions. So it will show us the data on how secondary air management system works under various operation conditions. And from simulation software, we can utilize the industry standard simulation software like MATLAB or Simulink to assess the performance of different optimization strategies for secondary air management system. And move on to component analysis. So we can do component testing, which will conduct bench tests on individuals secondary air management system components, including air injection pumps, valve, to evaluate the efficiency and durability. And under the component analysis, we can do material analysis, that show the performance of. And second, under component analysis, we can perform material analysis to identify the suitable material for enhancing the durability and reliability of secondary air management system components. Move on to control algorithm development. Under algorithm, we can do design, which we can develop the advanced control algorithms for precise and adaptive secondary air injection during cold starts. We also can do real-time feedback, which integrates sensors to provide real-time feedback on exhaust gas temperature, air fuel ratio, and other relevant parameters for closed-loop control. Next, energy efficiency evaluation. Through energy consumption measurement, we can implement tests to measure the energy consumption of air injection pump under different operating conditions. We also can we can also explore strategies for improving the energy efficiency of the air injection pump, including variable speed and energy recovery system. So the next one is experimental testing. Under experimental testing, we can test the vehicle selection, which we can choose a representative range of vehicle covering different engine type and size for the testing. We can also do the on-road and dynometer testing, which is dynometer usually used for tuning the engine performance. We can conduct on-road and dynometer tests to evaluate the performance of optimized secondary air management system in real-world condition. On to data collection and analysis, which we can collect data on emission, fuel consumption, and system performance during the experimental tests. And we can also do statistical analysis, which we can use the method to analyze the collected data and assesses the significance of the observed improvement. And next is cost-benefit analysis, which we can evaluate the costs associated with implementing optimized secondary air management system, which we can considering the manufacturing, material, and integration expenses. We can also benefit from the analysis, which including potential fuel saving, emission reductions, and also long-term sustainability. And last is iterative optimization. Through this, we can use iterative process to implement an iterative optimization process based on the result obtained from simulation, component analysis, and experimental testing. We can also do a continuous improvement that can refine the secondary air management system optimization strategies based on the feedback from each phase of the study. And thank you. I will pass to my friend.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amshan Yusri. Next, I will present about analysis. There are 4 technical analysis. First of all is type of SAMS. Second, impact of emissions. 3, impact of engine performance. And lastly, maintenance and troubleshooting. First, type of SAMS. Passive systems utilize exhaust pressure fluctuation to blow in air. Advantages: simpler design, lower cost. Disadvantage: less control over air injection, potential less effective. Active system employ an electric pump to inject air. Advantage: precise control, higher efficiency. And disadvantage: increased complexity, higher cost, and potential pump failure. Next, impact of emissions. First, reduce unburned hydrocarbons (HC) and carbon monoxide (CO) during cold starts. Effectiveness depends on factors like air injection timing, exhaust temperature, and sensor accuracy. Next, impact of engine performance. Improve cold starting, leading to faster engine warm-up and smoother operation. May contribute to slightly higher fuel consumption at low engine temperatures. And lastly, maintenance and troubleshooting. Air pump valve and control unit require regular checks and potential replacement. Common issues include pump failure, valve leaks, and sensor malfunctions. That's all for me. Thank you.
Hi, Assalamualaikum. I will continue our presentation about result and discussion. The primary purpose of secondary air management system is to reduce harmful emission and improve engine performance, particularly during the critical cold start phase. Here are 3 points that I will separate. First point is cold start challenge. During cold start challenge, the engine run rich, meaning it uses more fuel than necessary for proper combustion. This excess fuel leads to first increased emission. Unburned hydrocarbon and carbon monoxide are released into atmosphere. Second, poor engine performance. Reduced power and efficiency due to incomplete combustion. Second point is secondary air management system to the rescue. Secondary air management system inject refresh air directly into the exhaust manifold downstream of the exhaust valve. This additional oxygen promotes more complete combustion of the rich fuel mixture, leading to first, reduced emission. Hydrocarbon and carbon monoxide are significantly minimized. Second, improve engine performance. Smoother running, better power delivery, and faster engine warm-up. Third point is functioning principle. Different secondary air management system configuration exists, but the basic principle involves first, a pump is provide fresh air circulation. Second, check valve. It prevents exhaust gas from backflowing into pump. Third, air injection valve. It controls the timing and direction of air injection based on engine temperature and other sensor input. Fourth and lastly, control unit. This monitor engine condition and electronically manage the air pump and valve operation. That's all about my presentation, and I will pass to my another friend. Thank you.